Hello there. In this video we're going to be looking at solving systems by substitution. So we're going to be solving these questions actually by hand. In previous videos we looked at solving them graphically, which we used our calculators, as well as graphing it by hand on a graph. But today we're going to actually be solving this without a graph, just by hand, using our algebra. So the reason it's called substitution is because the method that you're going to be using when you do this is you're substituting one equation into the other equation. And you'll see what that kind of means when we actually get to it. So our first example, it says solve the system by substitution. And we're given two equations. I'm going to just label one of these equations equation 1. So we'll call this one equation 1. And then we'll call this second one here equation number 2. So what we want to do is we want to put either equation 1 into equation number 2 or number 2 into equation number 1. So we're going to have to rearrange one and then substitute it into the other. So because equation number 2 is already y equals, what we can do is I can substitute that in where I see y in equation number 1. So the first step that we always want to do is convert one equation into y equals, but we've already done that. So we are going to substitute equation number 2 into equation number 1. So equation number 1 was currently this, x plus y equals 56, but now the y is going to change. So it's going to be x plus, and then the y was 7x plus 8. So I'm just going to put it in there like that, and then it was equals 56. So now this equation that I now have, it only has x's. So if it only has x's, that means that I can solve it. So I have an x plus a 7x, so total I'm going to have 8x. And then I have plus 8 equals 56. And to solve this, we just got to isolate for x there. So I am first going to subtract 8. Subtract 8. My 8's are going to cancel. So there's only an 8x left on this side. And then on the other side, I have 56 minus 8, which is going to give me 48. And then get rid of that 8 there by dividing by 8. These 8's will then cancel. And then x is going to equal 48 divided by 8. That is 6. So now that we have this, we have x is equal to 6, but we don't know what y is. So we need to figure out what y is by taking this 6 and substituting it back into one of the equations. So usually it's the one that's already rearranged into the y equals. So I'm just going to bring my work up. And what we're going to do is we're going to substitute x equals 6 back into equation 2. So equation number 2 was y equals 7x plus 8. And then the x is now going to become a 6. So it's 7 times 6 plus 8. And that's going to give us 7 times 6 is 42. And then plus 8. So adding those, we're going to get y is equal to 50. So now I know that y is 50 and x is 6. So I can write it as a point. Goes x first and then y, so it's going to be 6 and 50, and that's our answer. And just to remind you again, it goes x first and then y. Number 2 we got here, we have x plus 3y equals 7, and minus 4x plus 5y equals negative 96. So I'm going to do the same thing. I'm going to call this one equation 1, call this one equation 2. And now with this one, neither of them are x equals or y equals. Like this one we had, it was y equals, so that was nice to substitute in where we had a y. But with this one, we don't, so we're going to have to rearrange one. And now one of them is usually going to be easier than the other. So we're going to want to pick the easier one and then convert it into x equals or y equals. So in this case, I'm thinking equation number 1 looks a little easier, so I'm going to use that one. So equation 1, I'll just rewrite down here, was x plus 3y equals 7. And then I'm going to solve for it either x equals or y equals. Now y has something in front of it, so that's going to be harder. So I'm going to solve it in terms of x equals. So to get rid of this 3y, I will subtract 3y, and then I'll do the same on the other side, and then these will cancel. So on the left, I just have x, and on the right, I have 7 minus 3y. And then what I'm going to do with this is I'll take that and I will substitute that into equation 2. Okay, so the one that I haven't used yet, I've already used equation 1. I'm going to take this and sub it into equation 2. So equation 2 was this. It was negative 4x plus 5y equals negative 96. And then the x is going to change. So it was minus 4, and now the x is 7 minus 3y. Make sure you put it in brackets. And then we had plus 5y equals negative 96. So to solve for this, I'm first going to have to distribute this into my brackets there. So I'm going to have negative 4 times 7. That's going to be negative 28. Then I'm going to have negative 4 times negative 3y. That's positive 12y. And then plus 5y, and then equals negative 96. So I can take these y's and put these together. I'll just write down minus 28. And then I had plus 12y plus 5y, so that's plus 17y equals negative 96. And then again, we want to try to get this y by itself. So we're going to add 28. That'll get rid of the 28. And then do that on the other side. These 28s will cancel. So we only have 17y on the left. And then on the right side, negative 96 plus 28. That's going to give us negative 68. And then just divide by 17 on both sides so that these 17s can cancel. And then we just have y equals, it's going to be negative, and 68 divided by 17 is 4. And now that I know that y equals negative 4, I'm going to take that and we're going to have to sub it back into one of the equations. And you're always going to substitute it into the one that you've already done the rearranging on. So I knew that x was equal to 7 minus 3y, but then that y is going to change. So it's going to be x equals 7 minus 3 times, and then y is a negative 4. And then we'll solve and get what x is. So this is 7, and then a negative 3 times a negative 4, that's positive 12. And then 7 plus 12 is 19. So I know x is 19 and y is negative 4. So my point, my solution is 19 and negative 4. You could also state your final solution like this. You could say x equals 19 and y equals negative 4. That would also be acceptable. Number 3 is next here, and we have 6x plus 10y equals negative 23, and then negative 3x minus 40y equals 8. So again, I'm going to label these. We'll call this one equation 1, call this one equation 2, and then we want to rearrange one of these into x equals or y equals. Now all of these have something in front of the variable, so it doesn't really matter which one I pick to rearrange. It's going to be the same amount of work or the same amount of difficulty for any of them. So I am going to rearrange one of these, and I'm going to decide to rearrange equation 1, and I'm going to rearrange it into x equals. So we had 6x plus 10y equals negative 23. I'll first subtract 10y from both sides to get rid of my 10y. So I got 6x equals negative 23 minus 10y. And then divide by 6 on all of my terms to get rid of these 6's. So we get x equals negative 23 over 6 minus, and then we can actually simplify 10 over 6. You can divide 10 and 6 both by 2, so you'll get 5 over 3y. So what I'm going to do with this now is I'm going to take that and I'm going to substitute it into the other equation. So I'm going to substitute it into equation number 2. So equation number 2 is minus 3, and then it was times an x. And x is this right here. So it's going to be minus 23 over 6 minus 5 over 3y, and that's all in brackets being multiplied by the negative 3. And then we can just rewrite the rest of what we had. So we had minus 40y equals an 8. So I am first going to distribute this negative 3 into my brackets, so it's going to multiply to each of those. So with the first one, the two negatives are going to cancel, and it's going to give me something positive. And then I'll have 3 times 23 divided by 6. With the second one, again, the two negatives are going to cancel, and I'm going to get something positive. And it's going to be 5 times 3 divided by 3. And then there was also times y. And then we had a minus 40y, and then this equals an 8. So I'm going to take that work, and I'm just going to go back up to the top here now. But first I'm actually going to do some canceling down here. So this 3 and this 6, I can divide both of those by a 3. So that'll cancel to a 1, that'll cancel to a 2. Same with these 3's, those can both cancel there. So what I get out, I had a 23 over a 2, and then I had plus, and then we had a 5 and a y, then we had minus 40y equals 8. So these y's here I can put together, so I'll just leave the 23 over 2. I have 5y minus 40y, that's minus 35y equals 8. And again, we're trying to get this y by itself, so let's minus this 23 over 2 from both sides, minus 23 over 2. These will cancel on the left, so I just have minus 35y equals, and then these two, I can't subtract them, I need a common denominator. So picture the 8 as like 8 over 1, but we need this 1 to be a 2. So I will multiply by 2 in the denominator, and then I'll have to do the same in the numerator. So I get 16 over 2 minus 23 over 2. So now that they have a common denominator, now I can actually subtract them. So leave the left as the same, and then with this I'm going to have 16 minus 23, so that is going to give me negative 7 over 2. And then I still got to get rid of this negative 35, so I will divide by negative 35, and I'll do the same on the other side. But this one has a fraction, so instead I'm going to do it like this, divide by negative 35. So the negatives will cancel there, and all of this will cancel there. So I have y equals 7 over 2, and then rather than dividing by 35, what I'm going to do is I'm going to multiply, and I'll multiply by the reciprocal. This is a trick that you can use. And then I can do some canceling. I can divide 7 by 7, and I can divide 35 by 7. That'll give me a 5. So what I get out, I have y equals, and then when we multiply fractions, you multiply top with top. So we got 1 times 1, that's 1. And then 2 times 5, that is equal to a 10. And lastly, we just got to get what our x point is. So we got to take this, and we're going to substitute it back into the one that we had rearranged. So I'm going to substitute it into that one right there. So x is going to equal, it was negative 23 over 6, and then we had minus 5 over 3, and then timesing by y, but y is now a 10th. So we have that. And then I can do some canceling. This 5 and this 10 can both be divided by 5, so we're going to get that. So we have negative 23 over 6, and then with the second fraction it was minus, and then in the top we got 1 times 1, so that's just a 1. And then we have 3 times a 2, so that is going to be 6. So I can actually subtract those now. I just got negative 23 minus 1. That's negative 24. So it's negative 24 over 6, which that's equal to negative 4. So our final answer is negative 4. That's the x. And then our y was 1/10. So that one was definitely a lot harder. If you find these hard, don't get discouraged. They definitely are hard problems. So the last one we're going to do here is a word problem. We've seen a couple like this before dealing with money and people attending a show or a concert. So it says a concert had 220 people attend. Tickets cost $9 for adults and $6 for children. The concert collected $1,614 in ticket sales. How many adults and how many children attended the concert? So if we're going to be finding how many adults and how many children came to this, what we should do is we should label those as our variables. So I have x is equal to the number of children, and then y is equal to the number of adults. So I know that total we had 220 people. So if I add up all my children and all my adults, that's going to have to add up to 220. So if I take the children plus I take the adults, I add them together, I have to get 220 people. I also know that my adults is going to be $9 and my children are going to be $6. So if I had like 3 adults come, that's going to be $9 each. So 3 times 9, I would make 27 bucks. So it's going to be $9 times however many adults come. So that is y. I don't know how many there are. Got to use y. Plus, I'm also going to make money from the children, and they were $6 for every one that came. So times by however many came for the children, which was x. And when I add up all of that money, that has to add up to $1,614. So I'm going to label this one equation 1, and I'm going to label this one as equation 2. And I'm going to rearrange equation 1. I'm going to subtract an x from both sides, and then I will substitute that into equation 2. So what I'll get from this, I'm going to have y equals 220 minus x. So I'm going to take this and I'm going to substitute that where I have y right there. So I'm just going to do that down below. So it was 9 times y, but y is now 220 minus x. And then we had plus 6x equals 1,614. So we're going to distribute first into our brackets. So we're going to have 9 times 220, that is 1,980. And then we had 9 times minus x, that's minus 9x. And then plus 6x equals 1,614. So these x's I can put together. I'll just leave the 1,980. So minus 9x plus 6x, that is minus 3x equals 1,614. And then we want to get this x by itself, so let's get rid of this 1980. So we will subtract that from both sides. It's going to cancel on the left. So we just have minus 3x equals, and then 1,614 subtract 1,980 is negative 366. And then lastly, let's get rid of that negative 3. So we'll divide by negative 3, divide by negative 3. Those will cancel. So we have x is equal to, the negatives will cancel on the right, and 366 divided by 3 is 122. So we know what x is. Now we just got to figure out what y is, and I'll do that up here. So y, we had right here, it was 220 minus x. So 220 minus x. But I now know what x is. So it's going to be 220 minus 122. So y is going to be equal to, subtracting those two, I'm going to get 98. So now that I know that x is 122 and y equals 98, I can look back up and see that y is the number of adults. So that means I have 98 adults and x is 122. So that is 122 children. So I'm just going to write that at the bottom. So that is our final answer. And that was also our last question. So our homework questions are just here at the bottom. We're on page 474.